All right, I wanted to make a little video talking a little bit more about approximating the area underneath the curve. And I have my eraser selected and not my pen, so let me change it to my pen here. The idea is that you've got some sort of curve. I don't know what it looks like, something like this, f of x. And you've got an a and a b. You've got some sort of x coordinates down here. And what we're trying to do is find the area underneath this curve. And the idea, well, we'll do it that way. And the idea is what we're going to do is we're going to break it up into rectangles. That if I divide this up into rectangles, what I can do is I can find the area of each rectangle and add up the areas of those rectangles, and that'll give me an approximation of the area underneath the curve, depending on how you want to do it in there. And so there's several different strategies that we've come up of coming up with different rectangles, but the idea is that you want to find the area of these rectangles. Typically what we do is we look at the height of the rectangle and the width of the rectangle, and you multiply those two together to get the area underneath that curve. So you want to look at what's the height of each rectangle, what's the width, and then add up the rectangles that you have for each one of the things that you have. Okay? And so, this vertical can be, something that you read off a graph or a measurement or something like that. Or it can be something based on the function itself. So if I've got, if I know my function, so let's do an example maybe with some numbers. Let's take y equals x squared, and we'll go from a equals 1 to a equals 3 with 4 rectangles. So n is going to be the number of rectangles. My starting value is going to be 1, my ending value is going to be 3, and I'm looking at y equals x squared. Okay, and you got sort of two options. You got a left-hand sum or a right-hand sum. Let's do the right hand to start with. So I know that when x is equal to 1, y is equal to 1, right? That's the point 1, 1. When x is equal to 2, y is equal to 4. And when x is equal to 3, y is up here at 9. 5, 6, 7, 8, 9, something like way up here. And we get that nice sort of curve shape going like that. And so what I want to do is I want to approximate that with 4 rectangles. So I'm going to divide this up into 4 pieces. It would be 1, 1.5, 2, 2.5, 3. That's going to divide us up into 4 regions down here. The width of those rectangles, the width of these here, the width of those is going to be 1/2. And what I want to do to find, if I'm doing the right-hand rule, I'm going to use the right side of that rectangle to determine my height. And so the height of this rectangle would be the same as the y value on this curve when x is equal to 1.5. And so the height would be 1.5 squared. It's going to be the y value at that particular point, 1.5 squared, which I believe is 2.25. And so the area of this first rectangle, A1, would be 1/2 times 2.25, or 1.125. And then when I go on and make the next rectangle, my next rectangle is in here. The width is 1/2, and the height, well, it matches up on our curve, y equals x squared, and I know that x is equal to 2 on this side of the rectangle. And so the height of this rectangle is going to be 2 squared, or 4. And so area number 2 is going to have a width of 1/2 and a height of 4. And so that would have a total area of 2 in here. 1/2 times 4 would be 2 square units. And then our third rectangle, using the right-hand rule, is going to have still the width would be the same width all the way across, but the height is going to be 2.5 squared, which is 6.25, I believe. 2 times 2 is 4. Yeah, 6.25. It should be 6.25. And so area number 3 would be 1/2 times 6.25, or 3.125. And then area 4, the fourth rectangle here, it's going to be this rectangle here, A4. It has a width of a 1/2, and the height here, based on the would be 9. It's going to be 3 squared. I know that the y value along this side of the rectangle is 9, so it's going to be 3 squared, which is 9, right? It's going to be 3. The x-coordinate is 3. I know the y-coordinate can be found by using y equals 1/2 x. So the area of that point is going to be 1/2 times 9, so 4.5. And so our approximation of the area would be the sum of those. If you add them up, we're going to get 4, 5, 6, 7, 8, 9, 10, 10, and that's another 0.25, 10.75, I think is what we get for the area, is an approximation there of the area. Okay, and that's using the right-hand rule on there to find that area. We could have just as easily used the left-hand rule instead of drawing my rectangles this way. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I draw my graph, oops, 3, 9, 2, 4, 1, 1, 0, 0. So here's the y equals x squared graph again. I could have just as easily drawn my rectangles starting at the left-hand rule. And again, if I'm splitting it up into 4 rectangles, I'm going to have a rectangle here at 1.5 and one at 2.5. And so I also could draw my rectangles this way. Here's area 1, here's area 2, here's area 3, and here would be area 4. And I can find my rectangles that way. The height of this first one, A1, is 1 unit tall, right? The y-coordinate here of this thing is 1. So it would be 1 times 1/2. The width is still 1/2. For 1.5, the height here, it's not 2, it's 2.125. The height is going to be 1.5 squared times 1/2 for area number 2. So 2.25 times 1/2, which would be 1.125. Okay, and area 3, so this area here would be 1.135. Area 3 is our rectangle here. The height when x is equal to 2 would be 2 squared, and the width is 1/2. We're still a 1/2 unit between values there. So I'm looking at 4 times 1/2, and so that area would be 2. That first area was 1/2. And area 4, I'm going to get my height here from 2.5 squared. The width is still 1/2. So 2.5 times 2.5 is 6.25 multiplied by 1/2 gives us 3.125. And so this approximation using the left side approximation would be, my area is about, let me get my eraser again here. area is approximately 1/2 plus 1.125 plus 2 plus 3.125 would be the sum of those values, which is 2, 3, 6, 6.75. Okay, and so what I can get from here is that my left-hand sum area is that it's 6.75, or using the right-hand sum, I got an area of 10.75. So looking at the picture, this area is an underestimate. The area underneath the curve, I'm leaving out all of this area in here. That area didn't get added into my sum. That's the area that's underneath the curve, but it's not within my rectangle. So I'm coming up short with the 6.25. But if I did the right-hand sum, I'd be adding in this extra area. So I know that this 10.75 is too big. So it's somewhere between 6.75 and 10.75. I know that area in there is somewhere in between those two. I could get a better estimate by using more rectangles, but that's more calculation, more work I have to do in there. So you kind of have to balance how much calculation do you want to do with how many rectangles you want to do in there to find that area, how accurate you want to be in there. But the idea is we're approximating the area underneath the curve by coming up with rectangles, and the vertical distance on that is the distance from the x-axis up to our curve. You can get it by plugging in the corresponding x value, or you can also do it if you have some sort of other measurement way of getting what that vertical y value is. You can do it that vertical y value. But you've got rectangles. You got just a bunch of rectangles that you're looking at here, and the area is length times width, or width times, usually we call this the width and this is the height, to get the area of those rectangles. The horizontal distance is usually the width, and the vertical we call the height. Doesn't really matter how you do it, but that gives you an approximation of the area underneath the curve. So there we go.